Hey guys, welcome back. Steve here with 6 Star Automotive. Today we're going to continue our scope series with episode 2. Before we get started, I want to solidify the basics of what we discussed on the last episode so we can kind of expand on those and then go into some real-world testing. So pretty much all modern scopes are going to have presets to help you get to the waveform that you're trying to get to faster. And they're great, and I wouldn't say don't use them, but just like anything, they can be a crutch. So if you don't understand how they're built and why they are the way that they are, then if it doesn't work out for you, you're like, up in the air, you don't know what to do. So I'm going to show you how to go around the preset, just in case a preset doesn't work for you. That way you understand what that preset is built from. So if you have to find another way to get to the waveform, you already know how and you're not crutched with those presets. So to recap what we talked about last time, we have our voltage scale here, time base here. This is going to be your trigger, so it's either going to be automatic or you have a single function, a normal function, and then there's a hold function if you actually catch something. And there's another function that this scope allows too that I just found out. So if you go into here, restart it, and go down to auto setup, there is a fit function, and this is super cool. So if you watch here, see how it's 0.1, the time base and the voltage scale are adjusting automatically for whatever signal it's seeing. So see, right now it's tweaking itself around trying to grab onto a signal. We'll do some real world testing here in a little bit, and I'll show you how that works and maybe how you can use it to your advantage. So understanding how this scope works is really going to help you use it faster. So obviously left and right buttons here, up and down buttons here. These buttons, when they're in this view, are going to change where your readings are. So 1 volt, 2 volts per division, 5 down, 0.5 volts, and then we can go right to our time base, milliseconds per division, 10, 20, 100. We already talked about this last time. This is the controlling our trigger. We have scan, signal, and normal. Most of the time you're going to want it in normal, but you might want to start in scan to kind of make sure that it grabs onto that signal. So we're going to go over to the trigger. So this line, your trigger is actually your intersection between this, you see here, this guy up top, so this central line, and then this line here. That is where your trigger. So your trigger is technically that dot right there, but wherever this line crosses that line in relation to this guy is where that trigger is actually set. So you can bring it up to like here in the center. So it's not here, right? It's here. And you can move this as well. So let's do that really fast just so you understand. We're going to go to menu. We're going to go to trigger. If you don't want it in the center, you can move it to grid left. So now see how it's over on this side? Or grid center. They don't give you a grid right. You get grid left or grid center. That way it shows, like if you're trying to catch it on an upslope, you want to catch it right here. So if you have like a really long waveform that does like so, or comes around, you're catching it on the upslope or the downslope right here in this first division rather than in the center division like you would here. Most of the time though, you're going to want it here, but just know that that's how you get to it. Let's get to it again. So we go to menu, trigger, TRH position, and that's your horizontal position. Trigger window, trigger slope. So see, we can change the slope. See here, this is a slower way of changing your slope. We're going to have an upslope. Trigger level. This is going to change our trigger level. Trigger mode. Trigger mode is going to change this. So I mean, this is just again a longer, slower way of doing what is already available in another. But you cannot change this trigger position unless you come into here that I know of. And then the rest of these are just, you have your short versions of getting to where you need to get. So you have your slope you can change here. So it'll tell you up in this top right corner whatever you're selected on. So see how it says slope? If we go over, now it says invert. So we're invert yes, invert no. You can go down or up or just keep cycling up, up, up. Either way, at this point we're going to invert no. Alrighty, so let's connect. So this tool is great. This is an amp probe, a low amp probe. So if you look here, this guy will do 20 to 60 amps. So what it's doing is it's taking the magnetic field around the wire and it's able to do the calculations to determine how much amperage is going in there, and it measures that on the scope with millivolts. So you have 100 millivolts per amp or 10 millivolts per amp to get into a 20 amp range or a 60 amp range. These things have a battery in them, so you have to be careful. They do need to be powered, so make sure you turn that guy off because it will kill your battery. I mean, I guess they'll turn off automatically. I think this one will too. I think there's actually a setting in here where if you hold the 0 button and then you kick it on, it will disable its auto off function. Might have to look that up though. Anyway, so I'm going to show you some really awesome functionality of this guy, and these things can be, you know, anywhere from $60. I think I paid for this guy up to like $300, and however much you want to spend. But this guy is a pretty good deal for the money. I ended up getting the one with BNC, so I had to get an adapter to banana. They do sell it with banana, so if that's what you want, then you know you can get adapters back the other direction too. You know, if you have Pico, you're going to want BNC, but if you have pretty much anything else, you're going to want banana. But it doesn't really matter. They make relatively cheap adapters for this stuff. So this U-scope has a micro BNC. This is a special connector that I've actually only seen on the U-scope, but anyway, pretty easy to connect. Just goes in right there. And then I've got an adapter on this guy to get to banana. I think it's not very expensive on AES Wave. One skill that's really vital to have is understanding what a coil amp ramp looks like. If you've ever messed with a Subaru, you know that the coils are buried way down there. That's a coil right there. I'm going to do a couple of things at once. I'm going to show you how to test for a coil amp ramp, and then I'm going to show you how in the scope you can use your basics and your fundamentals to get the best picture. And I've got a lot of stuff for you. It's going to be pretty cool. Check this out. In this Subaru, most of the time what you're going to want to do is you're going to want to find the wire at the coil way down there and wrap this guy around that wire. So there's a couple ways of doing this. If you have an engine where it's on top and you can just get to the coils, like this guy over here, see here, we've got coils right on the top. We can just easily hook around this wire. Easy peasy, lemon squeezy, figure out which wire is which. I don't want to do it on this engine because this is so easy, and I don't just want to show you the easiest way of doing it. But say you're on this example and you want to check a coil amp ramp. Holy cow. All right, well, let's take a look. I got an idea. What you can do is you pull open your fuse box and look in here. If it's not a Ford, you'll be able to see some information. So in this case, we don't get fuse numbers, which is lame. But what we do see here, this looks like injector. So maybe that powers all the injectors. That'd be pretty sweet. And then what about this? E engine GI. Looks like the only, and G2. So I'm betting something in this area powers those coils. Let's take a look at the repair information. So doing diagnosis correctly takes a little bit of time. You're just going to have to accept that. Okay, so we looked up our vehicle. We have our vehicle here. We're going to go to diagrams. We're going to go to, remember what we talked about in one of the last videos. We're going to go to the interactive color non-OE, and then we're going to go to powertrain management. You can do this faster, right, by doing this search bar and having another crutch, but I'm trying to teach you how to do this without a crutch. So go to diagrams, go to powertrain management, is right here. This is where that search bar is going. And then remember, if you click into this, you're going to bring up all of them in one shot. And then if we search around for a bit, we'll find, what do we got here? Cylinder bank ignition coil. Alrighty, let's zoom in on this. And we can see that there's a common right here. See how they have white? White is common between all these. So remember, in ALLDATA, what you can do is you can click on this wire and it will highlight that whole wire. Now we're going to trace that wire back, and it tells us it's coming from fuse number 23. If you remember when we looked at the fuse box, it didn't give us the fuse numbers. So, not really the end of the world. We're going to go to the top, we're going to duplicate a tab. Okay, that's going to bring up another tab that's the same, so we still have our old tab here so we can go back and review, but now we just duplicated it. All right, so now we're going to go to vehicle level again, and if you come over here to the right, we'll see locations, fuses, and fusible links. Okay, now check this out. Here we go. Now we're going to zoom. Number 23. Okay, so we have, if we're looking at the fuse box thusly, we have the relays 1, 2, 3, and then we're going to go up 1, 2, 3, 4, 5, 6 to get to number 23. Let's go. Alrighty. 1, 2, 3. 1, 2, 3, 4, 5, 6. Grab our fuse tool. Grab that one. It was this one. We're going to yank it. Okay? So now we know that this is the one that powers all of our coils. If you take this tool, right here, these guys, AES Wave, great. Okay, so this is one of those like micro stubbies, but these regular micros, this is like super micro, whatever, mega maca micro, this guy will still go in there. So that guy goes in, and now we have a loop. So we're still allowing the power to go through and fuse it. So now we have our low amp probe. Turn the guy on, always turn on our scope. So see, we actually do have where it says primary ignition current. Actually, I'm gonna hit this auto setup and see what happens. So auto setup, that's going to let the probe do whatever it feels like doing, and we're gonna start the car. All right, we've got the car started. We're going to take our probe, and these are polarity sensitive. So if you go this way versus this way, you'll get a different reading. So let's we're going to grab this reading and take a look at our scope. Look at that. Okay, so that's pretty cool. It kind of, watch, I'm going to take it off, and you see how it's changing those volts per division, 50 millivolts, 20 millivolts, 10 millivolts, 5, 2, 1, pico, and now it's going into microseconds, and I'm going to hook it on again, right? So now we're going to watch this, we're going to hook it. We got a hook. Now let's watch it do its changes. 0.2 volts per second, 5 millivolts, and it's in that fit range. So now that it's got kind of an idea of what we're looking at, I'm going to move it out of that fit range. I'm going to go over. I'm going to go down to now normal. And see, but what it did is it moved our ground position. I don't really like that. And ground position is kind of a hassle to change, but that's a good thing to know. So we're going to go over to menu. We're going to do our vertical, and then we're going to go down to ground position. And see here, it's at -20. We're going to move that guy down, because in this case, we're only looking at a positive waveform. The waveform never goes below ground. So there's no point in us having to use up all of our space vertically for any kind of negative by having the ground really high like this. It cuts off the top of our waveform. So in this case, we want to keep that ground position nice and low. So let's do it like this. That looks fine. And now we'll hit OK. All right, now we can go back over to our... So now what we can do is, this is a good waveform, but it doesn't give us a lot of detail. We really want to see what's going on here. And remember, this is actually a parade pattern. So actually, we'll get to that in a second, because we're doing all of the coils at once. But ignore that for now. Imagine we're looking at one coil. That is the downside of doing this test this way, is that you're not looking at like that coil. You're looking at all the coils at once. But see how fast this is. And we can deal with that in a minute. So let's go to, we're going to change our voltage per division. See how, so this is good. So now we have 0.2 volts per division. It gives us the maximum amount of screen that we want to work with. That's great. So let's go to our time scale, and we're going to increase. Always go the wrong way first. Remember, you're always going to go the wrong way first. But see, now this is another great thing. So now we have our slope on the downside. So we actually want to see the slope on the upside. So that will give us a better a way of getting this in the center of the screen. So we're going to go over to our slope. Remember, see at the top here, it's going to say slope. And then that's where we are, right there on slope. We're going to change it to slope up. All right, good. And then we can go back to our time scale, and we can get it into the screen. And again, remember, so we talked about the trigger being right here in this line. So you can see right there where the trigger here crosses the trigger there is going to be where this is. So what cool thing that you can do is we'll go back to our trigger setting, which is here, and we'll bring our trigger up and watch what happens to the waveform. You can center it because of how this trigger slopes. So as you go higher with your trigger, it crosses there, so it's going to move your waveform to a more center and ideal position inside of that, inside of the screen. So let's go back to our milliseconds again, and now see, we can look at this. So what you're looking at here, this is a good ignition primary coil ramp waveform. It should be gradual. It can move around like this. They tend to do this. They'll go slow, and then they'll speed up toward the end, and then they'll cap off, and then they'll drop off here. But there are some very important details to this that you need to understand. So first and foremost is the very beginning. This is the most important part of this waveform. So what we're going to do is move this back here. Let's get this thing to actually be where we want it to be. There we go. And we're going to move this trigger down low. And what that'll allow us to do is zoom in specifically to the very beginning of that waveform where I want to show you what's going on. Right here. So this part is extremely important. This is the most important part of this waveform. So what we did is we took our waveform and we zoomed in really, really close, right on that initial, what's called a turn-on oscillation. So what you want to see are those little ripples right there. Those ripples are called turn-on oscillations. Not extremely important to know exactly what's happening here, but I'm going to explain it to you anyway. An ignition coil is basically a transformer. It has two coils of wire, primary and secondary, wound around an iron core inside. This causes a magnetic field to build up around that iron core. That changing magnetic field induces a small voltage into the secondary. At that point, the system is suddenly exposed to a rapid change in current and magnetic flux. Because the coil is an inductive circuit, this rapid change causes the magnetic field and the current to oscillate or ring before stabilizing. That's why you see that small ripple or oscillation or on the turn-on edge of the waveform. It's not extremely important to know all that technical jargon, but it is important to understand that it should be there, because if you don't see that, what you'll usually end up seeing in a bad coil is that this ramp right here, instead of having that turn-on oscillation and being gradual, will be like wham, straight up and down. So in a bad coil, instead of seeing that gradual turn-on with the oscillations at the beginning, you'll see an immediate like 90-degree spike, bang, right there, and then it'll start to look like the rest of this waveform. Really, if you have those turn-on oscillations, you don't have a bad coil. Second part is you want to make sure that you have a nice, smooth, gradual increase to the top. And then generally in most coils, you're going to see this, you're going to end up seeing this saturation point, or this stopping point where the current just sits still. This is generally caused by a current limiting resistor that stops the current from going any higher than this. So the coil becomes saturated, and then you have a little bit of time at the saturation point, and then it fires. And that's where you see the drop back down to zero. And technically, you should see oscillations there as well. So let's do the same thing here. We have it on the downslope now. So you see what I just did? So now we're crossing at the downslope. And now we'll go back over time scale and we will slow it down, and look at that. That is exactly what you're looking for. So this is a more pronounced version, but you see those turn-off oscillations. Same thing. It's just the opposite of what I was saying before. I guess a good way to say it is the leftover energy that's in the coil is resonating after the spark is depleted, and then that is shown in the primary as well. But it shows a healthy circuit, so that's something that you just want to make sure that you understand, is that those oscillations are good. You should have them there. So in this case, we know that everything is actually good. I'm just showing you how to look at these. But let's say everything isn't good. I'm going to move this back. Say, because we're looking at, let's move this. Okay, in this case, it's all of the coils firing, not just one. So if we did have one bad coil, we would only see it in one of these, because this is actually going cylinder 1342, 1342, 1342. So what you would end up seeing in real life is that you would see good, 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 bang, good, 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 bang, good, 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 bang. So this test, which is really fast, remember, will get you to, I'm not seeing an intermittent spike here, so I'm not really too concerned about having a bad coil. If I did see a spike here, which would mean one of these was bad, usually at that point your code is going to be for that cylinder, right? So you have a P0301 and you have one of these that's bad. You still should verify by getting right, you're going to need a 2-channel at this point, because what you need to do is you need to look at this waveform, but you also need something to trigger to tell you which one of these that it is. Or you would have to go down individually and you have to test at every individual coil. You would know that the injector signal and the signal that's closest to it would be for that cylinder, and then you just count it off by firing order. 1342, whatever the firing order is, you can just look that up in all data, easy enough. And then you can say, okay, now I know that it is cylinder 3 that ends up having the bad coil. And then you can tell without even having to pull it out, because scope. So that primary ignition waveform is something you really need to understand and master. Grab a car and play with it and figure that out. Remember, we're working on signal channel. We'll eventually get to multi-channel. We're not there yet. Just relax. We'll get there. Another common test that is relatively easy to perform, and say you have a crank no start. All right, you don't have any codes. The first thing that you want to do, this is just a quick tip. Anytime you have a crank no start, I'm going to give you guys a second to put in the comments, what do you do first? If you think about this logically, the most time-saving thing to do would be to spray some alternate fuel in the intake. Because think about what that would do. If you spray some alternate fuel into the intake on a crank no start, if it starts, what does it tell you? If it starts, you do not have an ignition problem, you don't have a compression problem, you don't have a computer problem, you don't have a key problem, you don't have any of that. All that, if it starts, you know you have a fuel problem because all you did was add fuel. If it doesn't start, then okay, well, you're gonna have to go other places. But it's a very quick, easy way, especially on a Chevy pickup, to determine if you might need to look into that fuel system. So let's say in this case, car came in on the hook, we pushed it in, had somebody crank it, sprayed some carb clean. Don't use brake clean, Ascander, Danner, phosgene gas, all that nonsense. Use carb clean, little spray. If it starts to fire off, get into that fuel system. But what you can do, I'll show you how you can do this with a scope. So again, we're going to go back to the inside of our box and we're going to look at, there we go, you see that? I just saw it, fuel, 20 amp. So we're starting on the side, over 1, 2, 3, 4, 5, 20 amp. So we're going to go here, 1, 2, 3, 4, 5, 20 amp there. We're going to grab our awesome AES wave amp loop, okay? So now we're just adding a loop into the circuit quickly and easily, and we're going to start the car. All right, scope on, amp clamp hooked up. Always zero your amp clamp, hit your 0 button. We're just gonna hit lab scope. Actually, let's do what we did last time. Actually, I liked how fast that was. So let's go down to auto setup, and I'm gonna hook. We're going to see what this guy comes up with. See how well this auto setup works. You got anything for me? Am I going to have to do all this myself? Whatever, I'm used to it. This is kind of what I was talking about. You don't necessarily just want to trust the scope to do everything for you. So if we go like so, we have this invert. Yes, there we go. Oh, I see. So remember what we talked about. I'm going to keep it here. So all I'm going to do is take this and I'm going to switch it. And now it's down underneath, see? So this is actually, I think, the way it's supposed to be. So we're going to go back to invert. I mean, this doesn't really matter, right? But just for the sake of teaching, because this is polarity sensitive, if you flip it around thusly, you're going to get a signal that's backwards. It doesn't matter. I mean, do you want to hit invert or do you want to spin this thing around? I guess it really depends on how easy whichever one is. If it's easier to flip it, flip it. If it's easier to invert it. Doesn't really matter. So let's go over. We're going to go to our voltage. There we go. There we go. And again, with the ground position, we might want to tweak with that. But in this case, we can still see it. It's on the screen. I'm going to try and get it a little closer first. We're going to go increase or decrease. Yeah, there we go. Milliseconds, 1 millisecond. And then 500 microseconds. So 1 millisecond. Okay, so what are we actually looking at here? So let's get our ground position. I'm going to go to our vertical. We're going to say yes. We're going to ground position. We're going to lower it some to get this a little bit more in the center of the screen. Okay. So what you're looking at here, this is the waveform on your fuel pump. So these are the commutator bumps. So generally speaking, most fuel pumps are going to have 8 commutator segments. We're looking for even commutator pumps. We want to see that they're all going to the same amount, they're all drawing the same amount of current, and they're all relatively uniform. So that tells us that we have a healthy fuel pump. If we have a fuel pump that is intermittently getting stuck, because what happens on a crank no start is the fuel pump just stops spinning. That's why if you bang on it with a hammer, you shock the fuel pump and it starts the commutator and it starts spinning, and then the fuel pump will work. But if you look at this waveform, you'll see that one of those humps or a couple will be trash. I mean, they'll be either small or they'll be really high or they'll be jagged, and the rest will look okay. So that means you have a bad commutator inside of your fuel pump motor. And you didn't have to disassemble anything. That's why this is so cool. So you can tell by looking at the waveform, what do you know? Right now, you already know that you have a complete circuit from the fuse all the way to the pump and to ground. If you have a waveform at all, you have current flow, which means you have power and you have ground. You have to. So now you know the circuit integrity is good. And if you have a bad commutator segment, you know that the fuel pump is bad. So you didn't even have to drop the pump. All you had to do was bust out your scope, look at the commutator waveform and say, I have 2 bad segments in my commutator. Sir, you need a fuel pump. If you believe that you have a bad fuel pump, you should go to the fuel pump connector and do your voltage drop tests. Watch the other videos that I have on voltage drop to understand what I'm talking about. Make sure you have power and ground and you don't have voltage drop in either one of those circuits. I mean, in this case, it's doing your due diligence. It's being professional. Since look how long this took us, right? Do your other tests. You really should be doing those. Alrighty, so just for giggles, in this case, we're going to take a look at one more signal. We're going to look at the crankshaft position sensor signal. So I looked up the diagram, same diagram we were at, and you can see here, top rear of engine crankshaft sensor. Okay, we know we're looking for a pink and a blue wire. I went back and I found crankshaft position sensor removal. Easy peasy, open the intake, there it is underneath the intake manifold. Really wasn't all that too difficult. I didn't have to remove this stuff, but I could see it. So what I did is I went under here, there's our crankshaft position sensor right there. And you can see I've got my T-pin and the pink wire and my meter grabbed on. Right, okay, so let's just turn on the scope. We've got our negative to ground, turn the scope on. We're just going to go to lab scope. And we're okay, now we're here. So you can see this is not perfect, but it's a good waveform so far. Let's go voltage. There we go. And see how it goes below. This is a good example of what we were talking about with ground position before. So let's hit our OK button. We're going to go to vertical. We're going to say ground position, and we're going to move our ground position up a little bit so we can see this waveform a little bit better. Okay, cool. Now we're going to scooch over. We're going to change our time scale. Okay, we're going to make this is great. This is fantastic. So you see what's happening is it's trying to put all this data on the screen, and it takes a while for it to buffer that and then show it. But what you can see is that we've got different spacing in here. So you see how this one has like 2 bumps and this one has 1 bump. And then it's got a bunch of other stuff in between. So let's move this a little bit. And this is what the computer needs to see, is it sees that the crank is spinning and there's certain teeth inside of that, in this case, the back of the engine, instead of the front, like a lot of them, they'll have teeth around a wheel, and then in between those, there will be a, let's see how to explain this. So here's a good example of what that looks like. As it's spinning, it'll say, okay, and this helps it determine the speed of rotation, and then this helps it determine the position. It knows that this big wide one is going to be, say it's like 3 teeth after that is going to be top dead center. It's a trigger point. So you don't want to know there went top dead center, there went top dead center. You want to know here comes top dead center, bang, here comes top dead center, bang. You know what I mean? That's why they have it like this, just so you understand why the signal has those funky waveforms in it. But what we're concerned about in this waveform is, does it all look uniform? Does it look like it should? And then again, is it even there, right? I mean, that's a big part of this, is do we even have a signal in the first place? So we have, in this case, we have a good signal. This is nice and even, it's nice and uniform, it's all the same amplitude, that looks happy. And if we have a crank no start, if we're concerned about a crank sensor, like say a crank sensor is common in this car, and we're testing at the sensor itself, and we do have signal, it might be a better idea, you know, in this case, because now, okay, say we do have signal at the crank sensor here, but does that really matter? I don't think it really matters, because what really matters is, do we have signal here, right? This guy needs to see it. If we do this test, and it's good, technically we need to do the test again here, because what if we have harness problem? You know what I mean? We can't say, oh, crank sensor is good, move on. Okay, well, even if it is good, it still may be our problem because this guy doesn't see it. So think about that when you're doing your testing. You know, just take a second, look at the problem and go, what tests can I perform? How quickly can I perform the tests that, you know, in this specific instance? And then if I do that test, what can bite me in the butt by doing that test? Like if I don't check the crank sensor at the PCM, then am I going to know? I mean, it kind of works both ways, right? So if you test at the PCM and it's not there, you're still going to have to test at the crank sensor, right? Because you can't go test it at the PCM, no sensor signal, bad crank sensor. Well, no, because what if you test directly at the crank sensor and it's there? Okay, well now you know that I have signal at the sensor but no signal at the PCM. I have a wiring harness problem. So, you know, you just have to think about those things, right? So think about, I'm going to turn the paperwork in. How can I be wrong? I don't want to be wrong. So how can I verify that I'm correct? You never want to leave an open in there. You want to close every door before you kick that diagnosis in. always try to break your own diagnosis before you send the paperwork up front. So this is called a WISE probe. I bought this because I had those little paddle probe things and I could never really get a decent signal out of it, and I didn't really like it. And this does give me a better signal. All right, so what I've got going on here is the WISE probe has, if you can see here, it splits off and it has a shunt. I don't know if that's the right word, but whatever. It has a ground. So that way, if there's ever an inductive spike that goes through your probe here, it doesn't and blow up your meter. It will go straight to ground. So that's that protection that this guy comes with, which is pretty cool. The idea of this is that it measures on this tip EMF. So, and it's pretty good at doing that. So what we're going to do is I'm going to hook up the lab scope. I'm going to start the car. And then we're looking at the ignition coil, right? The ignition coil is down here. And we can't really get to this thing. We can't do any kind of secondary ignition probing. But what we can do is that we can take this guy and we'll put him on the coil, like on the side of the coil. See what we got going here? Not really the front because I can't reach it, but at least I can get on the side of the coil. And then we can see what kind of waveform we can come up with. 2 milliseconds, because I don't know, I think so. Oh, look, we're starting to see something. Now let's move the voltage scale down. There we go. There we go. Okay, and then not auto, we want it to be normal. And that will, there we go. So then look at our trigger. We're going to move our trigger a little higher, and it's going to be moving it, always go backwards on this thing, to the upslope. There we go. So now you can see we have the upslope, we have our trigger, we have the normal, so it's going to stay in right where that trigger meets. And then we kind of have a, I mean, this is kind of what a primary, and this is my rub. Is that let's look at the signal, or the, you know, we've got the probe down on the coil. We're looking at our signal here, and it's, I mean, it's, so, you know, we have the coil on, the coil saturation, the KV spike, the burn line, and then the rest. So in this case, not really helping me a whole lot. You know, I mean, I can't see. This looks like trash, misfire garbage, even though we know this is known good. So, you know, I mean, I think that if you think about it for a second, here's another coil. I grabbed the other one next to it over here, cylinder 4, I think. And you can see, I mean, I think that really where this could shine is that it's a fast, easy way of determining a cylinder. I really think that that's probably the best. Like when you have a 2-channel scope, the best thing I believe that this is really helpful for is that instead of going and grabbing an attenuator and hooking onto a injector and then having to figure all that stuff out, you just hook up a second channel, hook up your WISE probe, touch something, right, that you know is that specific cylinder, say it's that coil, then you know, okay, that signal that is related to, like in my parade pattern of all the coils, that one is that coil, right? Then that'll be, then yeah, that's great. I think that that's great. But I mean, using that like as a, I'm going to look at ignition secondary with this, I don't know. I've yet to find, let's see if I've got enough gas left in my scope to take a look at this other one. And we'll look at it on the truck. So I'm grabbing onto the side of the coil here on the pick 'em up. And you can see, yeah, I mean, it's a, you know, it's a waveform, but it's kind of a crap waveform, you know, so I don't know. I mean, guys at AES Wave, tell me if I'm just an idiot. I mean, this is a 4-wire like we talked about, and I know you guys have said that they might be kind of meh for 4 wires. I mean, it's giving me a signal. It's just not giving me a signal where I can go, yeah, that's got a secondary misfire, or that's got a rich condition or a lean condition. I can't diagnose that, but I could at least say that is cylinder X. So, you know, I guess there's that. Alrighty, so you guys asked for a couple of samples of some common waveforms that I perform, and I gave you a couple of them. I mean, there's definitely more, but hope that helped. If you have any questions, you know where to leave them. If you have any critiques, you obviously know where to leave those. Thanks for watching. Catch you guys on the next one.